Welcome back to the beginner spring track here at Spring One. We're in the last stretch of it all, everyone. I hope you've been having a great day and a half so far. We've got another couple great presentations on deck. This next one, Bootiful GraphQL with Kotlin. Kotlin's a really hot commodity out there, so I'm really excited to hear about this one. Presenting it will be Dariusz Kutz and Guillaume Schebel, and we're excited to hear what they have to say. So, gentlemen, take it away.
Hello, everyone. I'm Dariusz Kutz, and welcome to Bootiful GraphQL Kotlin.
Hi, I'm Guillaume Schebel.
So we work at Expedia Group, which is a leading travel platform and consists of a number of companies besides Expedia, such as Vrbo, Hotels.com, Orbitz, Travelocity, and more. For the last couple of years, we've been building GraphQL APIs, and today we're going to demo some of the libraries that we open source as part of this effort. But before we jump to the demo, let's take a step back and do a quick refresher on some of the technologies that we're going to be using today. As the talk title implies, we will be using Spring Boot, which is one of the most popular web applications frameworks. It helps you to streamline, speed up, and bootstrap your application development process by automatically configuring your application with some sensible defaults, right? Through the means of those auto configurations, you can eliminate a lot of boilerplate code and focus on writing your business logic instead. There are a number of Spring Boot auto configurations available that help you integrate with any sort of technology out there, and it's very easy to create a custom one as well. Today, we're actually going to be using a custom auto configuration that we built that helps you create a reactive GraphQL server. It is built on Spring Webflux, which is a Spring reactive framework that allows you to build a fully asynchronous non-blocking applications. Today, we're also going to be using GraphQL, which is a querying language for your APIs. It is a specification that defines how to expose your data in some specific way, such that it's not only easily discoverable by your clients, but also allows them to selectively ask for the data that they want. Data is exposed through the means of a schema, which is a collection of documents that defines what sort of operations and data is available to your clients. GraphQL is strongly typed, which means that every field has to be resolved to some specific type, such as a primitive value like a string or a Boolean, some enum, a complex object that has a number of fields in it, or a list of any of those. So you cannot have a field that defines just an object like a row JSON. Everything has to be typed. Furthermore, GraphQL also makes a distinction between nullable and non-nullable types. And this contract is guaranteed by GraphQL. GraphQL does not dictate it's not tied to any specific database or storage technology. And it is up to the developers to decide where to get the data from and how they actually fetch it and how they expose it. In traditional best-dressed APIs, we work with the resources through the means of some endpoints, right? So you may have an endpoint for the users, another one for product, yet another one for reviews, etc., right? With GraphQL, you expose a single endpoint, by convention it's just /GraphQL, and every client has to explicitly ask for the data that they want. Since clients explicitly specify the data that they want, you can have a single endpoint that provides a fully customizable responses to each one of them. This is actually extremely important because in REST-based APIs, if you need to have data from multiple endpoints, well, you have to make multiple calls. Furthermore, if you have like something like a mobile client and desktop client, right, they may share some common set of data, but desktop client can actually ask for some additional data, right? Because they have much bigger screen to work with and maybe better bandwidth to download this data as well. And today we're also going to be using Kotlin, right? Kotlin is a great programming language, and it is a pleasure to work with. There are a number of features that that makes it a wonderful choice, but since GraphQL is a specification, right, and there are a number of implementations available in a number of languages, why choose Kotlin? Well, first of all, it is strongly typed and null. This allows you to model your Kotlin classes to match exactly your GraphQL schema. And since it's a statically typed language, you have actually compiler time guarantees around that. If you use data classes, you can also eliminate a lot of boilerplate code and simplify your code base. Full interop with Java, that's also extremely important, especially for us since we built a number of Java libraries over the years. So being able to use that rich ecosystem and continue to use them without the need for rewrite was kind of a must. And last but not least, well, coroutines are amazing. They allow you to write imperative code that is fully asynchronous. And as an end result, your code is not only easier to read and understand, but also leads to more maintainable code as well. Once you combine all of those together, well, we end up with GraphQL-kotlin, which is a set of libraries for running GraphQL in Kotlin. Today, we're going to be using GraphQL Kotlin Spring Server and GraphQL Kotlin Schema Generator. Schema Generator is built on top of GraphQL Java and helps you, well, build out a GraphQL schema. When you define your GraphQL server, you can actually start with two approaches. You can either start with a schema document first and then try to match your code to it. So you write your resolvers and data classes, and hopefully they will match your schema definition. Or you can go the other way around and write your code first and then generate your schema based on your source code. GraphQL Kotlin follows the code first approach, meaning that you simply write your functions returning data classes, and the library will automatically convert it to a GraphQL schema. This makes your code a single source of truth for defining the shape of the schema, and also makes your experience similar to writing traditional REST-based APIs. But when you actually create a GraphQL server, you need a few extra things besides the schema, right? So you need also well, some GraphQL runtime environment that can process the queries and dispatch the calls to different resolvers. And you also, at the minimum, need some endpoint to access your HTTP request, right? That's a lot of boilerplate code that you would have to specify over and over again when you develop new applications. That's why we created a GraphQL Kotlin Spring Server, which is our Spring Boot auto-configuration library that automatically pre-configures all the necessary beans to start a reactive GraphQL server. So without further ado, well, why don't we take a look at how it looks in practice, and let's move on to the demo.
All right, thank you very much. So I'm just going to share my screen. So Darius, you have to stop sharing yours before I can share mine. There we are. All right. So you should be able to now see my screen. So here is basically a live demo that we're going to make. Something very simple, rewriting the application that you've seen during the first part of the presentation. So we have a very simplistic Spring Boot application, basically the one you're going to get directly from starter.spring.io. You download that, you set up in your IDE, and you're good to go. The only addition we've made is effectively here in the middle, as you can see, one single dependency, GraphQL Kotlin Spring Server. As Josh mentioned, we are going the GraphQL Kotlin Spring Server is going not only doing the interfacing with Spring and Spring Boot via term configuration, but is going to make the interface with the GraphQL Schema Generator, so we can move from the code directly to GraphQL, pretty much the same way we do with REST APIs in the Spring world or with Hibernate in the database world. The only configuration we actually do need is in your application.yml, under the GraphQL part, which package, or packages in this case, we're allowed to expose outside. This gives us quite some control. And so, for example, if I had a package named com Expedia Group GraphQL services, and I don't list it here, the schema generator will basically fail if I ever try to expose some classes from that package. So, but here for today, we are taking everything under our demo project. In terms of application domain, classic, nothing fancy here. We haven't reconfigured everything. And so I'm just going to start by creating a new package. We are going to call that query, because we're going to deal with GraphQL queries in that package. And then a simple conference query. That is basically the same thing as you would have, again, normally in REST applications. And so we're going to have a class called conference query. The first thing we need to do is for the auto configure to do its job, we are going to start by saying it's a component. And in this case, we are talking about a Spring component, nothing fancy, just for dependency injection to work as we expect. The only addition we're going to make is basically to say it's a, here with an annotation, it's a, whoop, there's W. It's a query and it's a GraphQL query. If we look directly in here, it's just a markup interface. It doesn't add anything per se. It's just helping then the auto configure to pick up all the queries if we are on read operations, mutations if we are on write operations, and subscription if we are on string. So that's just for the auto configure to play its role. And then after that, we are going to start writing some code. So we are going to have a first function, here public function, which is called conference. I mean, we are talking about a conference, so let's make it simple. And we are directly going to return a new type conference, and the name will be Spring 1 2020. Here we're just going to not create an abstract class, create a class directly here, name, and you know what? Let's make it even simpler for us. We have a data class. Here is going to be a value directly, and that's it. And here I have already written some GraphQL code. So if I start my application, we're going to see a few things happening behind the scene. So Spring banner, classic. First thing that pops up in the log is the schema. So we, by default, done the schema that we joined directly here. As you can see, we have a type here, query. The type query can exposes a conference field. The conference field is of conference type, and it's non-nullable. The conference type itself, as you can expect, has a name and as a string. From a query perspective, so here I'm using an application called Playground. It's basically what you wish Swagger was. And because GraphQL is strongly typed and has a lot of features, we can directly have built-in documentation, and we can see the schema from the Playground. So here we see our query. It's a type, it's a conference, and we see the details. And if we had more complex and much richer schema, we would be able to go inside. And so the syntax here is going to be very simple. So we start with, it's a JSON-like syntax where, because I have a type or I have a schema, it's a strongly typed schema, I can just autocomplete. So I have a conference and I have, and that's per the GraphQL spec, I have to select all the fields I want inside of each of the nodes. So there is no wildcard, there's no nothing like this. And that when I will hit the request or hit the play button, is going to send an HTTP request on /GraphQL. That's configured by default on my application on port 8080, which is just started on the side. And here we can see that we have directly the result of, as we expect. We come back with a conference. We have the name, Spring 1 2020. That's brilliant. A few things to note about the HTTP protocol that's being used here. Unlike in the REST world where we have all the convention possible, usually in the GraphQL world, everything is sent in a post. The query here is sent as the payload of the post request, and it comes back with at least a data section. If we had errors, we would have a error block below data, and we can even have extensions that we can use for analytics or tracing capabilities. And if we have managed errors, so errors that are not just like 500 from the server, that can be managed directly inside of the GraphQL response, returning a 200, so the clients know where to pick the errors from and what to do with it. So that's much simpler from that perspective. All right, so let's move on a tiny bit with the code. So now we have this. Let's see what other kind of features we could have. So as I said, it's strong. We are strongly typed. It would be nice to have some kind of description or documentation here. So here I can just say, hey, GraphQL description, great place to meet people. I could use GraphQL description here, sorry, on the value itself or on any of the fields. In this case, I choose to use it directly in the on the type. And I'm going to show you another feature that's very interesting. Is here directly the deprecation and a quick message, no longer needed. So this is the Kotlin deprecation annotation, which we even could specify the replace with field, but I'm not going to use it right now. And in this case, we're going to translate that into the directly in the GraphQL schema, because GraphQL supports not only description but deprecation methods, which is very interesting again from an observability perspective on the server side and from a client perspective, so they know exactly what they should use and what they should be moving to. All right, so let's restart here. We're going to see how it looks like directly in the schema first, and then we're going to see the difference in the code. Okay, whoops, I have applications already running behind the scene. Let me just fix that very quickly. Yes, this one was running already. So just here, we have our description, right place to meet people, and we can see that our name here is deprecating. There is a message. So let's restart. So we're going to see that some of the effects in the playground. Okay, so our application is started. If I just here refresh, we can see that now. Let me just try to zoom in. There is an annotation here saying, okay, there is something happening with name. If I go over, oh, the field name in the conference type is deprecated with a message no longer needed. Again, that's great when you try to introspect and to see what's available directly in into an API. And here, if I go directly to my documentation, we have the great place to meet people available here. Depending on the kind of client you use, you can even use some Markdown, you can even use some markup technologies. And so having a very rich documentation directly provided in the schema with links, with highlighted text, and so on and so forth. And here we have the deprecation message as well. That is very interesting. All right, so let's move on a bit. Let's make it a bit more complex. So we have our conference type. Let's create new types. So here I'm going to create a few new types. The first one I want to show you is the interface. GraphQL, like Kotlin, supports polymorphism. In GraphQL, we have two kinds of polymorphism. We have what we call interfaces, which is just a markup which must include at least one property. And the property can be from a string, a number, another object, and so on and so forth. Or there is a type called union, which is, again, here a markup. And in that case, the difference with the union is there is no field, and each member of the union do pretty much what it wants. That's very interesting when you want to have polymorphic lists, as we're going to show that later. From a Kotlin perspective, we create a GraphQL interface with a Kotlin interface like I have here, and we put properties there. If I want to create a GraphQL union, same thing, I just don't put any field inside of my Kotlin interface. So here I have my type. Then I have different kinds of implementation of people. So we have attendees. Attendees have obviously a name and a kind of ticket. And the ticket here are enums. So that's a Kotlin enum, nothing new here, which is going to be translated then as a GraphQL enum with exactly the same name. Just to note that GraphQL enums don't support values. It's just going to be conference or workshop or full. if I put an identifier as in, for example, GraphQL will completely ignore it. Then I have a second type of people here, a speaker, and the speaker has a name, obviously, as it implements people, and a list of talks. I can directly go back to my query, and I can implement it where I have directly returned the list of people. So we have the first person who's not me. She's Jane. She has a full ticket type for the conference, and I'm the speaker with I'm a speaker with 2 talks. GraphQL is awesome, and graphql-kotlin is even better. So let's just start with this. We're starting the application one more time. There we go. Fix it up. Okay. So, and here you can see directly on the screen, it appears that I can still select people or conferences, and now I can select people. So let's just zoom into the syntax. The exclamation mark you can see is just meaning that the type is non-nullable. So that's a bit of gymnastic compared to Kotlin. In Kotlin, if a type is non-nullable, there is no markup. In GraphQL, if the type is non-nullable, there is an exclamation point. If the type was nullable, you wouldn't have any markup in GraphQL, but you would have the question mark in Kotlin. So that's a tiny bit of gymnastic we have to make the first times, but we're getting used to it. If you see a type here between brackets, it basically means it's a list, like an array. So effectively, my type people or my people here is a non-nullable list of non-nullable people. I could have a nullable list of nullable people or any kind of mix of the two. And inside of my people, I have the name, and then we can see that we have the attendees and we have the speakers. So let's see how it works from a query perspective. So here we have people. And from an autocompletion perspective, we could have just basically the names. Validation type field. What is going on? Oh, because here we have, let me just remove this. Validation error. Oh.
You misspelled people with popple.
Ah, thank you. Thank you very much. So let's go back to the normal thing. It's people, not popple. Okay, that's better. Thank you very much. There we are. Okay, so we have our conference, we have our people. It's Jane, it's Guillaume, great stuff. If I want to go inside of the implementation type, so attendees and speaker, I need to specify exactly what I need to select. So right now, I want to say, okay, if I'm on an attendee, I want to select, if I put the name here, that's going to be interesting. Nothing is changing because I've already selected the name at the interface level. There is no need for me to, if I basically say it in the implementation, it's a duplication, so we won't see a duplicated value coming back. But what I'm really interested in is the ticket. Obviously, if I'm on the speaker type, I'm interested in the list of talks. Because it's a list of a primitive type, I don't need to go deeper into the selection, but otherwise I would need to select, for example, if my talks were a type talk and I had, again, title, year, and so on and so forth, I would need to select each individual field. If I run this, we have Jane here with the type, the name, the ticket. I have Guillaume with his list of talks. And here's a secret field, something very interesting. If I want to know the effective type, the effective GraphQL type that is being returned, there are some kind of conventional field names like _type name, which if I execute this is basically giving me the type being returned for that object. So here we see that Jane with a full ticket is effectively an attendee. where Guillaume with the talks is a speaker. So that is very interesting. Sometimes it's very important when we are on the client side, so we can, the client knows which tab to instantiate. Things you would notice is I select at the same time my conferences and my people, and I can just do something like this, and I pick and choose whatever I want. Unlike when we're in the RESTful or HTTPS world, where we have to make a lot of HTTP requests going out. In this case, there is one single HTTP request going to the server, and then the server dispatches to the right resolvers. In this case, the functions I've written in my code. Okay, so now we are done with this. Let's create a tiny bit more code. So the first thing we're going to do is we're going to create the schedule of our conference. So here I'm creating a third function. I could have placed that into another query file with another query class like this. No problem. In this case, for the sake of the demo, I'm preferring adding everything to here. And I will create a class, put that into its own file. It's going to be here. And we're just going to change a tiny bit, a couple of stuff there. So here, oh, I don't want this. I will leave the class as is, and we'll just make the grading and the talks public by using the value markup. So my schema generator can just see it when we are going to go over. Something we didn't mention so far, as you probably have noticed, the schema generator, when we pass the query, is going to each public field, so in this case, all my functions, as I'm in a query, and then we look at the return type, here conference, and just go in its own public field and public functions, and generate the schema out of the types using reflection. It's as simple as that. If we put anything private, for example, or even protected, it's not going to appear in the GraphQL schema. So all we expose here is public. And so I have this, I have directly my schedule function, obviously a bit of a run here to show the difference. Okay, the application has restarted. And I'm just going to, for the sake of the visibility here, going to change. So now I can go say, oh, I want the schedule, and I want the greetings and the talks. Let's prettify that tiny bit, much better. As you can expect, that's our conference. We have the greeting welcome message, and we have the list of talks. I mean, we only have one speaker in our conference, so that's the only talks we have. But let's change that a tiny bit. So far, there is nothing new with the schedule compared to what we've been doing with the conferences or with the people. So let's just remove here the talks. And we're going to move it back inside of the schedule detail. As I mentioned a bit just earlier, we expose not only the public properties, but we expose as well the function. So here, we are going to see the, where is it? Scale query, scale function is the last one. Here we have this one. We're just going to add some logs because which application doesn't have logs, right? Here, that's a duplication, so we remove that talk here. So same list is being returned, but all we do is a log. And we're going to see a big difference by moving from a value to a function. So let's just restart. All right, awesome, it's restarted. Let's open our documentation, see if the change from value to function has changed anything. Let's refresh just in case of. Here, schedule, nothing has changed. I mean, we still see the talks property in my schedule details type, returning a non-nullable list of non-nullable string. And the string is called a scalar type, pretty much what you would expect as a primitive. It could be number, it could be float, booleans, a few things like this. Those are considered as scalar types. Let's see if my if I see anything different from my query, so I haven't changed the query itself, nothing is different when I return it. But now, hang on, let's look at the logs, because we did some logs. I mean, that's what you expect. I used and I selected the talks field to return the list of talks. We invoke directly the function. And obviously, because we invoke the function, we have returning the list of talks appearing. The interesting part is going to come now, where what happens if I don't select my list of talks? So let's just empty the logs. GraphQL-wise, all I get back is the greetings. Nothing is in the logs, because we only select or invoke functions if the associated field is selected. And that is super powerful. Now imagine if you have some service calls made in the talks function, some DB calls, a lot of very heavy computation done like this, just by not selecting the field, the client can gain in performance, because the client can select exactly what they want and they get what they need. They are going as fast as they can be. And so if you don't need to return some data, or if you know that some of your computation could be heavy, put them directly into a function. It's not going to change anything from a client in terms of GraphQL capabilities, but performance-wise, you might see a lot of good things. So here, if I put back the list of talks are coming back here, and we have Darkmagic, they're returning the list of talks log here. So that's great. We have already a way to very easily optimize something, and we are not tied to plain old Java object, or Kotlin in this case, data classes. We can just have a bit more and go into the function space and being able to invoke and to adjust our complete capabilities based on what is being asked by our customer or our clients. All right, so that's very easy. That's just like plain old GraphQL, a tiny bit of simple things. Let's go a tiny bit more into to the specification of why it's great to have Kotlin and Spring Boot. So here I have a list of talks, as I mentioned, and we've seen, it's only going to be invoked if I have something, the field is selected. So let's add some very heavy computation. So we're going to call some databases. I mean, we're going to simulate some call to a database. The first one is a call from a cache. And we're going to block the thread for 100 milliseconds, putting some logs, returning something. We have a call to a more heavy database, takes back 2 seconds, log, and we return a list. From a function perspective, we have, let me see, which one is it? The function. Lost for a second. Which one is it? Yes. Yes, sorry. Talks here. Okay, so we already have the logger, so we don't need to duplicate that. Our function, our talks function, here changes a tiny bit. So we have a first log here. We get our talks from our cache and database and just return them into a single list. If we rebuild, so nothing is going to change from a schema perspective. So that's pretty great. We still have our shell details, our talks here, as you can see directly in the console, nothing is changing. Here, my query just still passes. And if I run it, as you can expect, it takes, so we have here the jump of 100 milliseconds for the cache call, and then we have about 2 seconds for the talk to the database, and then we are going to return the list. If we look effectively at the logs, getting the list, got cache, got DB talks, returning, nothing fancy here. That's because we are, in this case, mono-threaded, or we are reusing the thread that where our HTTP request came in instead of native, directly reusing that thread. It works, there is no problem with that, but it's not really efficient. I mean, something that is great in GraphQL is to be able to do this. So here's a new feature in the language. And so if I do a double selection, pretty much what I showed you before with the names, I have a single call being done here. There is a kind of a deduplication done here. My result, even though I selected twice the field, is only coming back once. However, if I want to kind of force that kind of duplication, because it's important in my use case, I can do this here. We can have something called an alias. An alias is just basically saying, you know what? There is something different, so we're going to assign that very differently. And as you can expect, we have the first call to the schedule and the talks being processed, and then we have the other one processed sequentially. There is nothing fancy here. The problem is GraphQL guarantees us to pick and choose to run things in parallel if we look effectively at some implementation in GraphQL Java. But because we are in a single thread in terms of resolution of that GraphQL request, we are treating everything sequentially. And that's not the best. So something we can do is, as we mentioned a bit earlier, is to move to coroutines. So let's change here our DB calls. So our DB calls are now going to be based on coroutines. Tiny bit of imports are needed there. So coroutine delay. So changes here. Cache talk is now a suspendable function. It suspends the coroutine for 100 milliseconds as before, as we're doing with the thread. We log. Here we have a database talk. Same amount of time, 2 seconds. We log, we do something. Because we made those two functions suspendable, we have to adapt a tiny bit our function here. So we put it suspendable as well. We want to run that into a coroutine scope. That's the first thing. And then to be even more fast, and we want to start parallelizing some calls. So we are going to do some async here, async there, and we want to parallelize the two calls from to our databases. Return here is not needed. And all we need to do is to say, all right, we are going to return the list of talks when both of the coroutines are finished. If we just change that and restart our application. All right. So schema-wise, again, nothing has changed. We still have our list of talks being declared exactly the same way as our list of as before. But now if I return, so if I remove the logs, if I here click play, we see it's much faster. Things are starting to be played in parallel. And so I can just like having the response under the, otherwise it would be 4 seconds. Now it's pretty much 2 seconds because we kind of parallelized onto the slowest. So that is a great way to have a lot of processing very quick, and we can have a lot of good things here. All right, let's move a tiny bit on. So that's kind of like GraphQL Kotlin 101. There is one more thing I want to show you, which is the usage of a type that we call the context. So for the context, we are going to create a new package here because we're going to query. We're going to do a context. We're going to say it's a file here called custom context. Here to context. Let's just put the duplication here. So a context is basically the kind of object that you can play with during the interception of the GraphQL query before it hits your effectively your query resolvers. So your functions like conference, talks, and so on and so forth. And so here you can play a bit with HTTP requests, HTTP responses, classic interceptor work, you can extract some information and putting that into a specific object called GraphQL Context. And then that object, you can use it directly inside of each of the query resolver. So here's how it's going to look like. We are going to have a, first thing we're going to do is we remove gradings from here because we're going to make grading a tiny bit better. We're just going to remove it from there as well. And we are going to say context usage. Just a bit of import. So here I changed grading from a value to a function, nothing really specific here, but I extract from the context the list of languages. If it's the first one, actually I should put here a on null. If the first one is French, my grading will be bienvenue, otherwise going to be welcome to the list of talks. And remember, we extracted that value languages directly from the headers of our HTTP request. So if we move it here, we'll just restart the application. We're just going to zoom out a tiny bit. All right. So again, schema-wise, nothing has changed. If I refresh here, I run the same functions. Both are coming directly in English. I mean, we didn't say anything. And we are going just to flip that. So in GraphQL, in Playground, we can directly here specify the HTTP headers. So we're going to do that. It's just a small piece of JSON where here we say the accepted language is French in this case, and directly it comes back as French. You will note that in my schema, grading here doesn't accept any argument because we don't expose GraphQL context. That is kind of a internal object that we can pass in each of resolvers. And the GraphQL object is the same for everybody. The GraphQL context object is the same for all the functions I will resolve here. All right. So now we've been doing some server-side thing. I think it's time we move on to the client side. So Derek, back to you.
Well, thanks, Guillaume. So let me just share my screen real quick. All righty, so Playground is great, right? But that's not how you generally interact with the schema, right? How do you implement it? How do you actually connect it from your client, right? So I've created a sample application here that's just basically hello world. I got very basic build file, just Kotlin and configured application so we can run it from the command line. And what you want to get from the HTTP client that you interact with GraphQL is that it's type safe, and you can actually generate those data models at build time, right? So let's see how it actually works with GraphQL Kotlin. So we need to add first a plugin, which is Expedia Group GraphQL plugin. And we also need to, well, configure the plugin, right? So if we add the configuration here, let me just reload it. You can see you can either use the GraphQL extension that automatically configures the necessary tasks, or you can configure the task directly. When you use the extension, all what you need to do is specify the target endpoint for the GraphQL schema, which is just localhost in my case, and the target package that you want to put your generated classes. So if you want to actually execute it, right, we need to also add a dependency on the client, which in our case, I'm going to use the Spring-based web client. We also have the Cater one, and you can generate a custom one, but for this demo, let's use the web client. And now, once we have this set up, well, we need to have some queries, right? So I already started up Guillaume server. We got a greetings query, right? I run it, I get my data back. So if I copy the query, let's put it under the resources. So I got my greetings query, GraphQL. And let's also add one more. So I got a slightly more interesting one here. That's the conference query that selects all the fields from the server. So of interest here is, again, is the people query, which returns the polymorphic type of attendee and the speaker. I need to select the type name so I know how to serialize it to select which implementation there. And one other thing that Guillaume didn't show, that you can actually specify the arguments to it, because that's how you want to actually have it customize it, right? So instead of hard coding the arguments in my query, I am using a variable syntax, which means that I can select it and specify just variables and use the same template. So if I just copy this over, create file here, so I get my conference query, and with those two things, well, let's generate. So I just build it out. It's going to run introspection query and then generate the client based on the schema that was generated and the queries there. So if you look at our build, so I got my generated sources here. The greetings query is very simple. There's just takes an instance of GraphQL client, which is just an interface here, exposes a single execute method, which is suspendable, and returns us the result with a schedule and the greetings. Conference query is a little bit more interesting because it takes the variables now, which takes optional prefix, and the result has those three fields, right? Conference, schedule, and people. People is, again, an interface and has two implementation, attendee and the speaker. So we use the type name in Jackson to automatically convert it to appropriate types when you get it from the response from the server. One additional thing that I want to highlight is that when you request an enum, well, enum has a very strict definition of what values you got. It's basically a constraint string, right? Values. So if you have an older client running and you update your server to return some additional values, well, client doesn't know how to handle it, so it will actually blow up. So what we need to do is actually add the handling for the default value as well. So with this, well, let's take a look at how the integration will look like. So the methods are suspendable, so I'm just going to put it in the run blocking block. Let's create a client. It's our GraphQL web client. And I need to specify the URL, which is just my localhost 8080 and /GraphQL. Oops. And now let's create our first query, so greetings query, which is greetings query. I specify the client, and I get my greeting back. So this is the greetings query, execute. And I can just print out the response from it. So since it's all data classes, I can just run it, and it's going to print out a nice output and the logs here, actually, so just console out. So you can see I get my schedule details, reading, welcome, and stuff out. So let's create a conference query also. Oops, this one. And I specify the client. So now if I get my result back, I can do conference query, execute. But now I need to specify some additional details, right? So I need to specify the variables. So I need to do variables equals my variables, right? Since its name prefix is nullable, I don't have to specify it here. But so for now, I'll leave it empty, and I can select result the data, right? So if I now run it, you can see that I will get the results back with once it starts up. And it's thinking, and yay, we got the response back. So we got the conference schedule and actual attendee and speaker and the list of people. But customization is actually very important, right? And Spring Web Client allows you to do those customizations very easily. So what we can do is when we generate a client, we can specify that client's type is actually GraphQL client's type web client. So now if I regenerate my classes, you'll notice that they actually slightly changed. So instead of just having the execute by themselves with the variable sphere, I also have an extra lamp that I can pass in to customize the request body. So from here, I can just add in my header that's accept language French. And if I rerun it, I expect to have my first response in French and the other one to have a default English. So yes, it actually worked as expected. Obviously, the greetings, the client itself, you can also customize it with the builder. So you can specify your web client builder that can specify some filters on it, default headers, etc. You can do that as well. Those are global settings that you specify on builder that you can pass it over here. So with this, well, we're kind of rushing because it's end of time. Well, hopefully by now you notice how easy it is to create GraphQL server, how easy it is to use the GraphQL client as well. We got plenty of examples and fairly comprehensive documentation on our GitHub pages, so make sure to check it out. Follow us on Twitter, and well, thanks everyone for watching, and let's move on to the Q&A.
Back. Thank you, gentlemen. That was so great to have you share with everyone. And if people need to hear more, they can go to the Q&A, which is going to be happening directly after this. Dariush and Guillaume will be over there to answer any of your questions. So make sure you go to the Spring One beginner-friendly Slack channel, and a Zoom link will be posted there. And then you can go off to the Q&A to talk more beautiful GraphQL with Kotlin with those fine gentlemen. Thank you again so much. We have our last presentation of the day set up, and I am so excited for this one. Two of my favorite people in the world, not just that I work with, but in the world, are about to present. So please stick around and see you at 5 minutes past the hour.